And look at this one. Now, all you have to do is count how many of each element. We've already kind of done that where you've counted before. We had Wednesday, which was called Mole Day. And Mole Day was just based upon counting number of atoms. Okay? So when we look at this, the iron hydroxide, we just count. So when we look at that, how many irons do we have? How many moles? 1 mole of iron. Okay? A mole is just a count. It's all it is. It represents a certain number of irons. Okay? We're not going to really talk about that count. It's really big. But it just represents a count. So how many oxygens do we have? So that 3 distributes to both of these. So how many oxygens do we have? 3. You have 3 moles of oxygen. Okay? And then we also have 3 moles of hydrogen. Is that correct? Now, I'm doing an example up above so you can see it worked out. So then when you look on the periodic table, there's these weights that represent a number of atoms that would be 1 mole of atoms. So when you look at iron, iron is 55.85 grams. For every 1 mole, you have that many grams of iron. You guys see what I'm looking at for iron? If you don't, look at iron. It's element number 26. You find its weight. It actually goes out a little bit further, but you guys, if you want to round, like I did, you can do that. Then you look at oxygen, and it's 15.9994, which is 16. Okay? And then when you look at hydrogen, it's 1.0079. That's 1.01. Okay. Everybody with me?
Yeah.
Okay? So then when you multiply those out, you got to multiply them out so they can get their total weight that they contribute. You get each of their weights. And then you add them all up, and that's where they come up with 106.87 grams. Any questions with that? So they're saying, if I have 1 mole of this compound, it's going to have that weight when I add everything up. So when I add everything up, that's the weight of it. Okay? Now, on this one, it wants us to find the percent oxygen. So what's the percent oxygen? That's all they want. So how much total weight in this compound is oxygen? How much is oxygen?
Do you want me to use my calculator?
No, we already did it. How much total grams is oxygen? 48 grams. Of the total, 106 grams, a total is 48. So you take the 48 divided by what? The total. You always find percent by taking a weight of something that makes that total up and divide it by a total. So, for example, if you got a 48 out of 50 on the test in here, what's the percent?
98.
Close. 96.
Oh.
Okay? Because you take 48 divided by 50. 50 is the total number of points, times it by 100, you get 96%. This is anything different. You take the 48 divided by 106.87 times 100. You get your percent. It's 44.9%. Okay, a little bit, then you'll find out. You'll have a lot of compounds that'll have a lot of oxygen in them. A lot of minerals have a lot of oxygen in them. Okay? Because why do you think a lot of minerals have a lot of oxygen in?
There's just a lot of oxygen out there.
Yeah, there's oxygen in the air. And oxygen is reactive where nitrogen's not. See, nitrogen is not reactive with hardly anything. Oxygen in the air is. So you're going to have a lot of compounds that have a lot of oxygen in there. It's going to have some hydrogen in there too, but more like oxygen. So
Did you get that, Jack?
I'm going to have you do this, the last one. Okay, I want you to go ahead. Should take any less than 5 minutes to do. I want you to find the percent zinc in that compound. And then I'll show you how that translates to your...
We're gonna have to.
So you guys can have your phone out for a calculator if you want to. I don't want you working on the Chromebooks yet. You guys will have plenty of time to do that. I need you to find,
Where's the zinc at?
follow what I just did and find the percent zinc in that compound, okay? And then we'll go over it. You just have to know if it's outside the parentheses, how it distributes through. It's the same as math, so I mean, you know those rules. So then you just have to look up each of their weights. Our total is here, and we're finding zinc, which is this total we need to use. Not the six. Some students will use the 65.41 and then it'll mess them up because we actually have 3 moles of zinc in there, which is a total of 196. So you take the 196.23 divided by the total, 386.17 times 100. And that's your percent zinc. So if somebody had zinc, I think Drake had zinc,
Yep.
and when you would look at the percentage of that, all that weight that's coming out of that mineral, it's 50.8% by weight zinc. So half of the weight that's being taken out of a mineral, of this mineral, is zinc. So when you guys do your example, and I took somebody's, one of somebody's slides, they had slide 4 kind of done. I'm going to show you what you have to do on slide number 4. Okay? So, slide number 4, somebody had, this is, I won't use that. Well, I can use them as, okay, so she had copper. Okay? This is from 5th period. So she has copper, she has the 2 minerals, she even showed pictures of them, what they look like. Okay, that's the mineral ore that they come from. And so one of her minerals is chalcopyrite, and it's CuFeS2. So what she'll do on slide number 4, this is slide 3, she's going to find the percent of copper in that compound. And then she'll find the percent copper in this compound here. Okay, and you would follow the same steps. So you'd look up 1 copper, 1 iron, and 2 sulfurs, add everything up, then take the weight of copper divided by the total times 100. Same on this one. This one would be really easy. See, this one has a ton of copper in it. This will have a higher percentage than this one will. Because sulfur doesn't have much of a weight. You got 2 copper for every 1 sulfur. So this chalcocite would have a lot more copper content. Okay? Does everybody understand what you need to do then on 4?
Yeah.
Okay, based on 3.
We're doing Wednesday, right?
Yep. And then slide 6, I'll go through that with you on Monday. Some things to look for, because that's the toughest slide to come up with the processing of it. Basically, the purifying of this. So this copper needs to be purified. It needs to be in the pure form. Right now, this copper is in a form that's like a +4, and we need to get it into to be a 0. So we need to add electrons to this copper to get it to be 0. Okay? So, got the rest of the time to work on that. If you guys got questions or anything, you can put that sheet away. We'll complete it probably on Monday just to refresh your memories. So that worksheet you can put away, and then you can just work on your slideshow.